Hello, geometry students. Today we're going to find the length of the arcs of circles. And by length, I mean if we put a string down on that arc and then took it off and pulled it open and put that on a ruler, how long would it be? So that's different than the measurement of the arc of a circle. So be careful. You can be asked to find the measurement of an arc, which we talked about on the previous video, or you can be asked to find the length of the arc of a circle. And that means that you would put a string down on the arc, take it off, and measure it on a ruler. So that's what we're going to talk about today. And before we do, let me remind you that the circumference of a circle is the length of the piece all the way around the circle. So if you put string all the way around the circle and then took it off and opened it and measured it on a ruler, that would be the circumference of that circle. And the formula for how we find it is 2 pi r, or diameter times pi, either one, whichever formula you like, they're the same. And so the length all the way around the circle is the circumference, 2 pi r. And so before we go any further, let's pause and find the circumference of this circle. If we know the radius is 3, then 2 pi r gives us 6 pi. You can leave the length in terms of pi, but remember, pi is a number bigger than 3. So the real circumference is going to be bigger than 18 feet long. So pause, find the circumference of this circle, and then press play for the solution. For this one, be careful if you're using the formula 2 pi r. You have to remember that in this case, we're given the diameter, and so therefore the radius would just be 10. When you plug it into the formula, you get that the circumference is 20 pi for this circle. Now, the arc length is a fraction of that circumference. Arc length is a fraction of the circumference. So this arc here, arc AB, if we put a string on it, opened it, put it on a ruler to measure it, that would be a fraction of the whole circumference. What fraction? The way we figure out that fraction is we take the measurement of this arc that we're looking at and divide it by 360. That's the part of 360 that it represents. So pause and write this down on your paper, and we will be practicing it for the rest of the video. So if we want to find the arc length of arc XY, we have to find the fraction of the circumference. What is the fraction? This fraction here is 90 degrees over 360, which will reduce to 1/4. And then we need to find the circumference of the whole circle. What part of the whole is that? Does that represent? Well, we know it's 2 pi r, or dr, d pi, pi d. So here it is. And so we can now take the fraction of the circumference and get our final answer. So pause, try on your own paper, and then press play for the solution. Notice this time the arc length that we're looking for is in red. We're given the radius of 15. We're given that this measurement of the red arc is 240. And so in order to find the arc length, it's going to be a fraction of the circumference. And what is the fraction? The fraction is 240 over 360. And what is the circumference? Well, we're given the radius, so we can say 2 pi r. And so we can plug those numbers in and calculate the length of that arc. So pause, practice this on your own paper, and then press play for the solution. We want to find the length of a semicircle with radius 1.3 meters. And you can leave your answer in terms of pi. First thing I would do is draw a picture. You could find the circumference. The circumference is 2 pi r. And then to find the length, it would be a fraction of the circumference. What fraction? Well, a semicircle is half of a circle, or 180 over 360. And when you plug that in, you can get your final answer, and you can leave it in terms of pi. That's how many meters long. So pause, practice on your own paper, and then press play. Here we're given that this arc is 60, so therefore this arc must be 120 if we use the arc addition postulate. And the first thing we can do is remind ourselves that if we're given the diameter, we could find the circumference by d pi, or we could do 2 pi r if we prefer, but remember the radius is 12. So arc length, this arc length is a fraction of the circumference. What fraction is it? It's 120 over 360, or a third. And the circumference is 2 pi r. And when you multiply that through, you get your final answer. So that does it for finding the length of the arcs of a circle. So I will leave you with this spring allium from my garden and wish you a great day.